To start to work with the MAUD, you should first download it. First Google the MAUD, then go to the site. You can easily find the download and start downloading according to the operation of your system. When the zip file is downloaded, you should extract the files inside that to use the MAUD. What you need for refinement is XRD format and CIF files. For this purpose, we can Google the CIF files of any crystal structure that we are studying. For example, here in TiO2 we have anatase and rutile as the two main phases. Here you can get access to the CIF format of the anatase structure and click on that to download the CIF file, and then you can change the name according to the phase. To load the data file, we should click on the file on the bar, then we can find the load data file. By clicking on that, we can get access to our XRD format file and load our XRD pattern on the MAUD. Then we can change the name according to the sample name, which is Degussa P25 here. Now you can go to the phases and load your CIF files to analyze the phases. First, I load the anatase file and try first refinement with the only phase of anatase. This is a recommendation in this case. Now we can load the CIF file of the rutile as a second phase to complete our refinement. Here you can see how rutile is loaded as a secondary phase, and we can do our refinement to proceed according to both phases. And you can see the parameters, and also you can repeat the refinement process. To check how accurate you have done this refinement, you can press the Control key and simultaneously press the M key to get access to the parameter RWP. If this parameter is below 10 or maximum 20, you can make sure that you have done this refinement very accurately. Then do the visual test to ensure that this refinement has been done correctly. You can get access to the results by clicking on Analysis on the menu, and then get the information related to the density and other structural parameters that are useful for you. Click on the sample box and then go to the parameters to see what's the volume and what weight percentage of each phase, including both anatase and rutile, in your sample, which is Degussa P25. Be careful about the results and parameters that you are looking for. It's recommended to check everything with the CIF file, the information in the crystal information file, that you can compare with the standard values there. Here I have used the Notepad++ to get access to the information written and in the CIF file. So you can use other softwares, but this software is the strongest one that I recommend. There are some models that can be used to enhance your refinement. One is SF model. instead of using the standard atomic models. This model enhances this refinement much significantly than you can use in some particular studies, but in this case the refinement was done very accurately, that there was no need for SF file. We don't see much change between two models, and we can also check the change in the phase percentage volume or weight percentage, and we see there is no change. So this model that we have used up to now is good and accurate enough for this study. Using Excel is a good option to compare results with the standard values. For this purpose, you can add the phases separately in different cells and start to enter the results, including the structural parameters, which is related to tetragonal structure. We have A and C for both cases. Also, we can get access to the positions of the cations and anions to also study if there is any oxygen displacement. Also, the distance and between the cations and anions can be evaluated easily by increasing the maximum distance here. I click on Control key and press C to copy the information, and use Control and pressing V to paste the information on the Excel cells easily, as you see here. And then I start to naming the information which are related to anatase phase, doing the same for the rutile phase to extract the information of structural related anion cation positions and the distance and angles between them, and also these A and C parameters, which are structural parameters. After entering the information of the rutile into our cell, we can easily compare everything and see what's the difference between these parameters and the standard value. Also, we can extract volume and weight percentage of each phase. In most of the cases, the Degussa 5 is mostly anatase based. It's around 80 to up to 90% anatase and 10% rutile phase. These information are accessible in most of the cases and most of the scientific reports that you can extract and compare them with. You can also get access to the information to the crystal size of each phase, but I highly recommend to do Schur equation and calculate manually to compare your results with these values. Based on my experience, the MAUD, I don't know why, but the crystal size are a little bit larger. Calculated and reported in this software. Maybe there is a technical issue. I'm not sure about that, but hopefully this will be solved and I will figure out in near future, and in my next video I will discuss on this aspect of this amazing software. Here these crystal sizes are reported in picometer, then you can convert it to nanometer by dividing by 10, as you see here. I start to insert new cells to enter the standard values to compare with these values. I again recommend using the Notepad++ as a very good and user-friendly software to extract the information of CIF files, including these structural parameters. As you see, they are quite near to the values that the software is calculated and refined parameters. Also, I do the same for the row tile to compare the structural parameters with what is refined there. To plot whatever you have refined here and the patterns that you are going to recognize from each other, related especially to each phase separately, you can right click on the part below the plot and then select the phase that you want to be clearly shown here. Also, you can extract the information and to save it in a separate file and then use it in other softwares to plot the pattern, and also each not only the total pattern but also the pattern of each phase.